Hi everyone, and welcome to today's lesson where we'll be multiplying and dividing real numbers. As we begin, let's talk about what kind of signs we get when we multiply with negative and positive numbers. First of all, we're used to multiplying positive numbers together, and so when we multiply a positive by a positive or divide a positive by a positive, the answer is positive. But what happens if we have a negative number? If we multiply one positive and one negative, or one negative and one positive, the answer will always be negative. However, if we put another negative in the mix and make it negative times negative, the answer will return back to a positive. So one negative changes the answer to negative, and a second negative will return it back to a positive. One way to think about this would be to think that two negative signs can be placed together to turn into a positive or a plus sign. Another easy way to remember this is to think about a little triangle that has two minus signs at the top and a plus at the bottom, kind of like a little alien face. If we multiply a negative and a negative, what we're left with is a positive. However, if we multiply a negative with a positive, we're left with a negative. So let's just do a couple of simple problems together. First, we have 7 times negative 4. Since we have one negative, that makes the answer negative, and we simply multiply 7 times 4 like normal, which is 28. So our answer is negative 28. In our second problem, notice we have a negative and a negative. Remember, the fraction is division, so we're really taking negative 42 and dividing it by negative 3. Two negatives make a positive, and 3 goes into 42 14 times, so our answer is positive 14. Notice in our last problem we're dividing a smaller number by a larger number, assuming we ignore this sign. So first I know a positive divided by a negative is a negative answer. Now I could divide 12 by 18, but what would happen is since 18 is larger than 12, I would need to add a decimal point and create a decimal answer. And although I could do that, I can also think of this as a fraction with 12 over 18, and I could simply reduce that fraction. Since 6 goes into 12 and 6 goes into 18, I could make this negative 2 over 3. Notice I do not leave the negative on the bottom of the fraction. I move it to the side or the top, but we would never want to leave a simplified answer that looks like this. The next problem looks a little more confusing. We have a negative 6 over 4/5. Keep in mind, however, that this is also a division sign. So what I really have is negative 6 divided by 4/5. I can think of this as negative 6 over 1. I always change dividing a fraction to multiplying by the reciprocal. So this is really negative 6 over 1 times 5 over 4. I should reduce. 2 goes into 4, 2 goes into 6. I now have negative 3, I'm going to move my negative up there, times 5, which is negative 15, over positive 2. I could divide this and turn this into a mixed number, leave the negative to the side and simply divide 2 into 15, that goes 7 times, with 1 left over, which would be 1 over 2. So I could have negative 7½ or negative 15/2. In our next example, notice that we have a negative over a negative. These two negatives will combine to make a positive. So I'm going to go ahead and cross those off and make them positive. But that positive will multiply with a negative to return the answer back to a negative. So I already know that my final answer will be negative. Another way to think about this is that because there's an odd number of negative signs, the answer will automatically be negative because the two here will pair up to make a positive. Now I want to reduce again before I multiply. So I can reduce the 2 and the 4 to a 1 and a 2. I now have positive 3 times negative 1, which is negative 3, over 2 times 5, which is 10. And notice I have negative 3 over 10. I do have a negative answer. In our next example, we're going to look at some decimals. We start by multiplying negative 0.8 times negative 0.2. We know that the two negatives will make a positive answer. In order to multiply decimals, we can simply ignore the decimal point and multiply the numbers together. That would simply be 8 times 2, which is 16. Now we count the number of decimal places. Since there's one in each problem, that would make 2 decimal places, and so I want to have 2 decimal places in my answer, making that 0.16. Now I'm going to have 0.16 divided by 0.4. We can't divide by a decimal, so we need to change that to a whole number. I can do that by moving the decimal point one place to the right and turning that into a 4. That's like multiplying by 10. So whatever I do here, I also need to do to the number that's being divided, so I'm going to move the decimal place over one place. I now have 1.6 divided by 4. When I divide 4 into 1.6, it's the same as dividing 4 into 16. I simply put the decimal point above in the problem. So 4 goes into 16 4 times, and my final answer would be 0.4. But what happens when I have to use exponents with negative numbers? Notice this says, what is the difference between negative 3 to the second power and the quantity negative 3 to the second power? In the first problem, I am simply squaring the 3. The reason for that is the exponent belongs only to the number that's in front of it. So in this case, 3 is squared. But there's a negative sitting in front. So this is negative 3 times 3, which is negative 9. In the second problem, I am squaring everything in the parentheses. So both the negative and the 3 are squared, meaning negative 3 times negative 3, which is positive 9. So I get two different answers. So just remember, in the first problem, only the 3 is squared. But in the second problem, both the 3 and the negative sign are squared. So parentheses do make a difference when we're working with exponents. So let's look at a problem where we're going to evaluate. Notice we have x to the fourth minus 2x, but x is negative 2. Evaluate means we're going to substitute negative 2 in for x and find the value. In this case, this says that x needs to be to the fourth power, but x is negative 2. If I were to simply substitute by writing this, I would not be taking the negative to the fourth power. I would simply be applying that to the 2. So it's important that I actually insert a parentheses in this problem so that I can take both the negative and the 2 to the fourth power. In other words, my problem should look something like this. Negative 2 in parentheses to the fourth power minus 2 times negative 2. Now I want to evaluate my exponents, so I take negative 2 times negative 2 times negative 2 times negative 2. Since I have 4 negatives, or an even number of negatives, my answer will be positive, and that makes positive 16. Then we have minus 2 times negative 2. Treat this as two negative signs, which would make a positive 4, and we then have positive 16 plus 4. which would be a final answer of 20. In our next problem, notice that although there's a negative in this problem, the exponent does not apply to it because the exponent only goes with m. So when I take my exponent of 2, I want to square just the m, or just the 5. So when I rewrite this, I would write negative and then in parentheses 5 squared minus 4 times 5. 5 squared is 25, so I have negative 25 minus 20 because 4 times 5 is 20. Negative 25 minus 20 is negative 45. Now we have one final example to look at together. This looks like it could be a little confusing because I have x over y, and both x and y are fractions. If I were to write these the way it is written, I would write x over y. So we have a fraction built within a fraction. But remember, x over y simply means x is divided by y. So a better way to write this might be negative 3/4 divided by negative 2/3. I need to multiply by the reciprocal, so I'm going to change this problem to negative 3/4 multiplied by negative 3/2. A negative times a negative is a positive, and so I have positive 9, 3 times 3 is 9, over 8 from 4 times 2. So this would be 9 over 8, or if I want to change it to a mixed number, 8 goes into 9 one time, with a remainder of 1 left over, 1 1/8. So that's the end of today's lesson. Thank you for watching.